So the higher this number is, the more likely we will be able to crack the key. As you can see, this number is increasing very fast because, like I said, this is a busy network that is being used at the moment by my own computers and my own devices. If yours isn't increasing fast, then don't worry, we will tackle this problem in the next lectures. So for now, we're capturing a lot of data, and this should actually be enough to crack the key. So what I'm gonna do, I'm gonna go down to my other terminal in here, and if we actually list the files, you'll see that we have the capture file that we specified in the right argument, and like I said, we're always interested in the .cap file. So all we have to do right now is do step 2 in here, run aircrack-ng against the file that we captured in order to crack the key. So I'm gonna do aircrack-ng, followed by the file name, which is basicweb01.cap. I'm gonna hit enter, and as you can see, it's telling us that the key is found. So let me cancel this here. And right now, we can connect to the target network, which is called test AP3, using this ASCII password. So you can literally just copy this and paste it, or you can connect using this key. Now, in some cases, you will not see this ASCII password. That's why I'm going to show you how to connect using this key right here, because you'll always get this. So I'm going to copy this, and I'm just going to paste it here. You can paste it anywhere in a normal text editor or anywhere you want. And all you have to do is remove the colons that we see in here between the numbers. So I'm going to remove this one, going to remove this one, and this. And now we can just copy this. And just to show you, I'm actually going to connect from my host machine. You can connect from Kali, but when we enabled monitor mode, we killed a lot of processes, and sometimes even after you restart these processes, getting connected to your target will be a little bit buggy. So it's best to literally just restart Kali and connect again. So just to save all of this time, I'm going to connect from here. I'm just going to click here. I'm going to connect to test AP3, and I'm going to paste the password. So I'm just going to click on show the password to show it to you. Again, the same password, we just removed the colons. I'm going to click on join. And as you can see, we managed to connect, and we can test this connection by going to Google. And perfect. As you can see, it's working, and we managed to break the WEP encryption. The first encryption that we'll learn how to break is called WEP, or Wired Equivalent Privacy. This is an old encryption that can be easily broken. The reason why I'm still covering it in this course is, first of all, because like I said, it's very simple, so it's a good starting point. Also, it's still used sometimes in some networks. Therefore, you can't really call yourself a hacker, and then if you see a network that uses web, you'll get stuck and you won't even be able to break into it. So, in this lecture, I'm going to explain how web works and what's the weakness that we can use to break it. And in the next lecture, you'll see how we can use this weakness in order to break web and get the key for any network that uses WEP. So basically, WEP uses an algorithm called RC4 to encrypt its data. So the way this works is basically, if a client wants to send something to the router, and let's say it wants to send this text data to send to the router, it'll first encrypt this using a key. Therefore, this normal text will be converted into gibberish, as you can see here. This encrypted packet will be sent into the air. So if a hacker captures this packet, as we've seen before, if we open this packet, we'll see that it's full of gibberish. Even though it actually contains useful information, we won't be able to read it because it's encrypted. The access point will receive this encrypted packet, and it'll be able to transform it back to its original form because it has the key. Therefore, it'll actually be able to read the contents, which is data to send to the router. The same happens if the router wants to send something back to the client. It'll first encrypt it using a key, send it to the client. The client will be able to decrypt it because it has the key. So the concept is always the same. The transmitter encrypts the data using a key, sends it to the receiver. The receiver is able to decrypt it because it also has the key. Therefore, anybody who captures the packet in the middle, they will get the packet, but they won't be able to see the contents because they do not have the key. So the algorithm and the way RC4 works is actually fine. The problem is with the way that WEP implements this algorithm. And to understand this, let's zoom in a little bit more on each step. So going back to the first step, we have the client trying to send data to the router, and the data that it wants to send is data to send to the router. So in order to encrypt this, WEP tries to generate a unique key for each packet. So literally each packet that's sent into the air, it tries to create a new unique key for it. To do that, it generates a random 24-bit initialization vector. The initialization vector is then added to the password of the network, to the actual key that people use to connect to the network. This generates a key stream, and then this key stream is used to encrypt this packet and transform it into gibberish. So basically we have the key stream plus the data that we need to encrypt gives us the gibberish, and then the gibberish is sent into the air. But before sending this into the air, WEP will also append the initialization vector. This is the 24-bit random number that I said it creates in order to make sure that each packet has a unique key. The reason why it adds the initialization vector to the packet is because once the router receives this packet, it needs to be able to decrypt it. And to decrypt it, it needs the key and the IV. But the router already has the key, so there is no need to send that. Therefore, we just need to send it the IV. So, when the router receives the packet, it has the IV, it has the password or the key, so it can generate a key stream and then use that key stream to transform this gibberish into its original form and read the packet. So, if you think about what I said, you can probably guess what the weakness is. Basically, the IV is sent in plain text. So if you look at this, you can see the packet content is encrypted. So if someone captures this packet, they won't be able to read this, but they will be able to read the IV in plain text. Also, the size of the IV is only 24 bits. Now, considering the huge amount of traffic that can be generated on a Wi-Fi network, this number is not big enough, and the IVs will start getting repeated in a busy network. This makes WEP vulnerable to statistical attacks, so we can use a tool called AirCrackNG to determine the key stream once we have enough repeated IVs, and from that it will also be able to crack WEP and give us the key to the network. In the previous lecture, we've seen how easy it is to crack WEP. All we had to do is capture enough data and then run AirCrackNG to crack the encryption and give me the key. Now, one problem that we could face is if the network is not busy. If it's not busy, then the number of data will be increasing very slowly. Therefore, we're going to have to wait for a while before we have enough data to crack the key. So let me show you an example. I'm just going to run aerodumpng here and list all the networks around me. And you can see I have my test network, my test AP in here. It's using web. And if you look under the data, you'll see that it's at 0 and it's not increasing. And even if it's going to increase, it's going to increase very slowly. which means that I'm gonna have to be waiting for hours before I can crack this network. So a solution to this is to force the AP to generate new packets with new IVs. Now, before doing this, we need to associate with this network. So what I mean by associate is we need to tell this network that we want to communicate with it, because by default, access points ignore any requests they get unless the device has connected to this network or associated with it. So don't get this mixed up with connecting. We're still unable to connect to the network because we need the password to be able to connect to the network. But what we're doing right now is literally just telling the target network, look, I want to communicate with you. Don't ignore my requests. That's all we're doing. So it's something similar to what happens when you just click on the network when you want to connect to it. You still haven't put the password, you're just telling the target network, I want to communicate with you, please don't ignore me. So in this lecture, I'm going to show you how to associate with the target network so we can communicate with it. And in the next lecture, I'm going to show you how, once associated, we can inject packets into the network and force the number of data to increase very, very quickly. First, I'm going to run aerodump-ng against my target network, which has this BSSID. So I'm going to copy it. And we're going to use the exact same command that we've been using so far. So we're going to do aerodump-ng --BSSID, followed by the MAC address of my target, --channel, followed by the channel which my target is running on, which is 6. And we're going to store all of this, so we're going to do --write, and we'll call this file ARP replay because that's the name of the attack. And then I'm going to put my wireless adapter in monitor mode, which is mon0. So a very simple command that we done before. We're using aerodump-ng to capture data from a network with this MAC address running on this channel. We're storing everything in a file called ARP replay. I'm gonna hit enter, and as you can see, it's running against my target. And notice the data is increasing really, really slow, or it's actually not increasing at all right now. Now, to associate with this network, we're going to use a program called areplay-ng. So we're going to type areplay-ng, followed by --fake auth, because we want to do a fake authentication attack. We're going to put 0 because we only want to do this once. We're going to do -a to specify the MAC address of the target network. So I'm going to paste it. I've already copied it. Then we're going to do -h to specify the MAC address of my wireless adapter. And to get the MAC address of my wireless adapter, I'm going to do ifconfig. And it's the first 12 digits of the unspec field. Usually, you'd see it after the ether, but when you enable monitor mode, it'll show up like so. So I'm going to copy this. And I'm going to paste it here. And I'm going to replace the minuses with colons. And that's it. It's done. And finally, I'm just going to give the name of my wireless adapter in monitor mode. So a very simple command. We're using areplay-ng, which is a tool that can be used to run a number of attacks. And we've seen using this with the deauthentication attack. We're telling it that we want to run a fake authentication attack. We want to do this once. We're giving it the MAC address of my target network after the A. Then I'm giving it the MAC address of my wireless adapter after the H. And finally, I'm giving it my wireless adapter in monitor mode. Now, before I run this, notice in here under the auth, we have nothing. And we don't have any clients showing up in here at the bottom. Now, if I hit enter, you can see under the auth, it's showing up as open. And you can see we have a new client here associated with the network. If you look in here, you'll see this is the MAC address of my target network, and right here is the MAC address of my wireless adapter. So right now I am associated with the target network, and if I send it anything, it's going to accept it and it's going to communicate with me. Again, I am not connected to the network. I still can't use the internet. I'm literally just associated with the network so I can communicate with it. Now, in the next lecture, I'm going to show you how we can communicate with this network in a way to force it into generating new packets with new IVs, which will allow us to crack the key very, very quickly. Now that we have associated with our target network, we can start communicating with it and it won't ignore us. So now we can go and start injecting packets into the traffic to force the access point to generate new packets with new IVs. This will increase the number of data really quickly, allowing us to crack WEP networks in minutes, even if the network was not busy like the one that we are targeting right now. Now, there are a number of ways to do this, but in this course I'm going to explain the most reliable method, which is using an ARP request replay attack. I actually explain other methods in my network hacking course, but they are a little bit more complex and have less success rate. So this is the most reliable method, and it should work against most networks if you have a good signal and a good wireless adapter. So the idea behind this method is to wait for an ARP packet, and I'll talk about ARP in more details later on. So for now, just think of it as a special type of a packet that we're going to be waiting on. Once this packet is sent in the network, we're going to capture it and retransmit it. Once we do this, the router is forced to generate a new packet with a new IV. So, by repeating this process, we will be forcing the router to continuously generate new packets with new IVs. Then, once we have enough data, once we have enough IVs, we can run AirCrackNG exactly as we seen before and crack the key. So let me show you how to do this in practice. Now, as you can see, I'm already running AeroDumpNG against my target network, and I have already associated with it as shown in the previous lecture. So the only thing that's left right now is to run the ARP replay attack in order to inject packets into the traffic and force the router to generate new packets and increase the number of data. To do that, we're going to use AReplayNG again, and the command is actually going to be very similar to this command right here. So I'm actually going to copy all of this because I'm lazy, and I'm going to clear this and paste the command here. Now, there are only a few things that I need to modify. First of all, I don't want to run a fake authentication attack, so I'm going to remove all of this, and I want to run an ARP replay attack. Also, this attack does not take a number, so I'm going to remove this number. And I'm also going to replace the A with a B. And we're done. So if you look at it, you'll see it's actually very similar to this command right here. We're using AReplayNG, but instead of doing a fake authentication attack, we're doing an ARP replay attack. We're giving it the MAC address of my target network after the B instead of the A. Then we're giving it the MAC address of my wireless adapter after the H, which is identical to this. And then we're giving it my wireless adapter in monitor mode. Now, I'm actually going to associate again before I do that. And then I'm going to hit enter here. And what's happening right now is my wireless adapter is waiting for an ARP packet. Once there is an ARP packet transmitted in this network, it's going to capture it and it's going to retransmit it. Once it does that, the access point will be forced to generate a new packet with a new IV, and we'll keep doing this, forcing the access point to continually generate new packets with new IVs. So you should just wait for it right now. We're literally just waiting for an ARP packet to be sent in the air. And as you can see, the number of data is increasing now very, very quickly, which means that we actually managed to capture an ARP packet. This ARP packet got retransmitted, forced the router to generate a new packet with a new IV, and we are continually doing this process, forcing the router to generate new packets with new IVs. So right now we can go ahead and run aircrack-ng to crack this network. And before I do that, I'll actually just associate one more time, and then I'm gonna do aircrack-ng and give it the name of the file which we're storing the data in, which is called arpreplay01.cap. So I'm gonna hit enter, and you'll notice the cracking process right now will actually require more data packets. The reason for this is I've actually modified the settings of this network so that it uses a 128-bit key, because in web you can either use a 64-bit or a 128-bit key, and obviously the 128 key is longer. Therefore, I actually modified the key length for this lecture to make sure it's the longest key possible, and as you can see, we still managed to get it within about 47,000 packets. We have the key right here in ASCII, and we have the key in here in hex, where we can use after we remove the colons. So perfect, now we managed to crack the target network. It was idle, as you could see, there was no data being sent, and we managed to do this by forcing the target access point to generate new packets with new IVs. In the previous lectures, we've seen how to crack the WEP encryption in minutes, even if the target network is not busy. Now, in the next lectures, we will talk about cracking WPA and WPA2. First of all, before we start talking about how to crack these encryptions, it is very important to understand that both of them are very, very similar. The only difference between them is the encryption used to ensure message integrity. WPA uses TKIP and WPA2 uses an encryption called CCMP. In any case, this does not affect the methods that we're going to use to crack WPA and WPA2. Therefore, all of the methods that I'm going to show you from now on will work on both WPA and WPA2. Now, both of these encryptions came after WEP, and they were designed to address the weaknesses in it. Therefore, both of them are much more secure, and cracking them is more challenging. So, before we start talking about how to crack them, I want to cover a feature that, if enabled and misconfigured, can be exploited to recover the key without having to crack the actual encryption. The feature is called WPS. It allows devices to connect to the network easily without having to enter the key for the network. So it was designed to simplify the process of connecting printers and such devices. You can actually see a WPS button on most wireless enabled printers. If this button is pressed and then you press the WPS button on the router, you'll notice that the printer will connect to the router without you having to enter the key. This way, the authentication is done using an 8-digit PIN. So you can think of this as a password made up of only numbers, and the length of this password is only 8. So this actually gives us a relatively small list of possible passwords, and we can try all of these possible passwords within a relatively short time. Once we get this PIN, it can be used to recover the actual WPA or WPA2 key. So as you can see, with this method, we are not exploiting WPA or WPA2. We are actually exploiting a feature that can be enabled on these encryptions. So for this to work, first of all, we need WPS to be enabled on the network because it can't be disabled. Also, it needs to be misconfigured, so it needs to be configured to use a normal pin authentication and not a push button authentication. If push button authentication is used, then the router will refuse any pins that we try unless the WPS button is pressed on the router. Therefore, the method will not work if push button or PBC is enabled. So in most modern routers, PBC comes enabled by default or WPS will be disabled by default, so this method might not work. But because WPA and WPA2 are so secure and so challenging, it is always a good idea to check if WPS is enabled and try the method that I'm going to show you to crack the network. If it fails, then you can try the other methods that I'm going to show you after the next lecture. Okay, now that we know what WPS is and how it can be used to recover the password for WPA and WPA2 networks, let's see how to do that in practice. So, right here I have my Kali machine. I've already enabled monitor mode on my wireless adapter on Mon0. Now usually we use AeroDump-ng to see all the networks around us. But right now, we want to see the networks that have WPS enabled, but because like I said, it's just a feature and people can turn this feature off. So, first of all, I'm going to use a tool called Wash to display all the networks around me that have WPS enabled. So, we're going to do wash --interface and give it my interface in monitor mode, which is Mon0. So all we're doing is wash is the name of the tool, interface to give it the interface, and Mon0 is my wireless adapter in monitor mode. If I hit enter now, you'll see it'll list my network straight away. Now I pressed Ctrl C to cancel this, similar to AeroDump-ng, because it'll keep running unless you cancel it. And you can see this is my target network. It's called test AP. It's giving us the vendor of the hardware used in this network, in this access point. The LCK tell us whether WPS is locked or not, because sometimes WPS locks after a number of failed attempts. So right now this says no, which means that we can actually go ahead and try to guess the pin. It's giving us the version of WPS. It's using version 1. The signal strength is in here, the channel, and the BSS ID. Now I explained the meaning of all of these things before in my AeroDump-ng lecture, so I'm not going to talk about them now. If you forgot the meaning of any of these terms, please go back to the AeroDump-ng lecture. Now this network actually uses WPA2, so just to confirm this to you, if I go here to my host machine and just try to connect to it, you'll see that it's telling me that this uses a WPA2 password. But like I said, we don't care if it's WPA or WPA2 because we're going to be exploiting a feature in these encryptions, which is the WPS feature. So now that we know our target network uses WPS, there is a good chance that this attack will work against it. The only reason it might fail is if the target uses PBC or push button authentication. Like I said, if the target uses PBC, then it will refuse all the pins unless the button is pressed on the router, and therefore this attack will fail. The only way to know is to literally try this attack and see if it works. So I'm going to copy the MAC address of this network or the BSS ID. And the first thing that I'm going to do, similar to what we did with WEP, I'm going to associate with the target network using a fake authentication attack. So basically, I'll be saying, I want to communicate with you, please don't ignore me, so that when I run the attack, the network will start accepting the pins and not ignore me. So to associate, we're going to use the exact same command that we used when we did it with WEP. So we're going to use AReplay-ng. We're going to tell it I want to run a fake authentication attack. We're going to give it the delay. So this is the time to wait between association attempts. Previously we set it to 0 and we had to do this manually every now and then. Right now I'm going to set it to 30 so that we associate with the target network every 30 seconds. Then I'm going to do -A to give it the MAC address of my target. and -H to give it the MAC address of my wireless adapter in monitor mode. And we've seen that we can get this by doing ifconfig and copy it from here. We said it's the first 12 digits. And I'll just replace the minus with the colon. And finally, I'm going to give it the name of my wireless adapter in monitor mode, which is mon0. So I explained this in details before. That's why I did it quickly. If you don't remember how I did this, please go back to the fake authentication attack lecture. So the command is ready now, but I'm not going to execute it. I'm going to go down to the bottom terminal and run Reaver, which is the program that will brute force the pin for me, and only then I will associate with the target, because otherwise areplay-ng will fail to associate with my network. So I'm going to move to this terminal right here. I'm going to clear the screen, and we're going to run Reaver, which is the program that's going to brute force the pin. So it's going to try every possible pin until it gets the right pin. Once it has the right pin, it'll use it to compute the actual WPA key. So using Reaver is very, very simple. It's very similar to everything we've been doing so far. So first of all, we have to type the program name, which is Reaver. Then I'm going to do --BSSID to give it the MAC address of my target network. So I'm just going to paste it. Then I'm going to do --channel and give it the channel of the target network, which is 1. Then we're going to do --interface and give it my wireless adapter in monitor mode, which is mon0. So a very, very simple command. We're using Reaver. This is the name of the program that will do the brute forcing for us and give us the key. We're giving it the BSSID, the MAC address of my target. We're doing --channel to give it the channel that my target is running on. And we're doing --interface to give it the name of my wireless adapter in monitor mode. I'm also going to add 2 more options. I'm going to add -VVV to show us as much information as possible. This is really helpful. If it fails or things go wrong, we'll be able to know what's happening, why things are going wrong. And I'm also going to do --no associate to tell Reaver not to associate with the target network, because we're already manually doing that in here. So Reaver can automatically do this step right here for you, but I've seen that it fails a lot. Therefore, it's actually better to do it ourselves manually here and then tell Reaver not to associate. So now I'm going to hit enter to get Reaver to work. And I'm going to go up to the top terminal and I'm going to hit enter to associate with the target network, telling it please don't ignore us, so that Reaver at the bottom here can brute force the pin and try every possible pin until we get the correct pin, which we'll use to get the password. Now, as you can see, right now I'm getting an error, and this is actually a bug with the latest versions of Reaver. So if you get this bug, this means they still haven't fixed it in the latest version, so it's better to go back and use an older version. I'm going to include an older version that works perfectly in the resources of this lecture, so you can access it from the top left of the lecture. If you tried Reaver and got this error right here, then go ahead and download this older version. Right now I already have it in my downloads right here, so you can see I'm in home downloads, and I have it right here called Reaver. So what I'm going to do is I'm going to clear this again, and I'm going to navigate to my downloads. So CD downloads, I'm going to list, and you can see we have it right here. Now it's already in green for me, but for you, you'd want to change the permissions of this file to an executable. So you'll have to do chmod +X Reaver. This will make it an executable. Once it is an executable, you can run it by doing ./ followed by its name, so Reaver. Then you can do the exact same command exactly like I just did it with the one that comes pre-installed in Kali. So I'm actually just going to go back to what I had, and I'm just going to go to the start of the command and put ./. So when we put the ./, we're basically running the file that is in the current working directory. We're running this. We're not running the normal Reaver file that is pre-installed in Kali. Then we're using all of the options exactly the same way that we were using it with the built-in one. I'm gonna hit enter. And as you can see right now, Reaver is trying the pin 1, 2, 3, 4, 5, 6, 7. And perfect. You can see the pin was actually 1, 2, 3, 4, 5, 6, 7, 0. So it's a simple pin. It actually came with this pin. So I didn't manually set this pin. My router came from the factory with WPS enabled with this pin. So like I said, this still works, but again, not against all routers. From that, it was able to discover the WPA key, which is UAU RWSXR, and the name of the router is TestAP. So I can literally go ahead and connect with this password, and I'll be able to connect to the network and see and decrypt all of the packets sent in the air. Now, if WPS is disabled on your target network, or if it's enabled but configured to use push button or PBC, then the method that I showed you in the previous lecture will not work. Therefore, you will have to go and crack the actual WPA or WPA2 encryption. And like I said, when these encryptions were designed, the developers knew about the weaknesses in WEP, and they made sure that they properly fixed these weaknesses. They actually did a pretty good job at this. Therefore, we cannot use the same method used in WEP to crack WPA and WPA2. So in WPA2, the keys are unique, they're temporary, they're much longer than what they were in WEP. Therefore, the packets sent in the air contain no information that is useful for us. So it doesn't matter, even if we capture 1 million packets, we can't use them to crack the key. The only packets that contain useful information are the handshake packets. These are 4 packets transferred between a client and the router when the client connects to the network. So in this lecture, I'm going to show you how to capture these packets, and in the next lectures, we'll see how to use them to crack the WPA or WPA2 key. First of all, as usual, you'd want to run aerodump-ng against all the networks around you. I've already done that, and as you can see, this is my target right here. It's using WPA2, and this is the MAC address. I'm going to copy it. And the first thing we'll do is just run aerodump-ng on this network and store the data in a file, exactly the same way that we used to do it with WEP. So we're just going to do aerodump-ng --bssid and give it the BSSID of my target, --channel, and give it the channel of my target, which is 1, --write, to specify a file name to store all the data that we're going to capture in. And let's call this WPA handshake, because we're going to capture the handshake. And finally, we're going to give it my wireless adapter in monitor mode, which is mon0. So very simple command. We've done this multiple times by now. We're using aerodump-ng. We're giving it the MAC address of my target after the BSSID. I'm giving it --channel to specify the channel of my target. I'm using --write to store all the data in a file. This file will contain everything that we capture. So if we capture the handshake, it will be in this file. And finally, I'm giving it the name of my wireless adapter in monitor mode. So now I'm going to hit enter. And as you can see, aerodump-ng is working against my target network. And right now, all we have to do is literally sit down and wait for the handshake to be captured. Like I said, the handshake is sent when a client connects to the network. So we'll literally have to sit down and wait until a new client connects to the network. Once a new client connects, we will capture the handshake, and you will see in here aerodump telling us that the handshake has been captured. Alternatively, we can use something that we learned before, which is a deauthentication attack. we know using that attack, we can disconnect a client from the network. So we can do this for a very short period of time. We can disconnect this client from the network. He will automatically connect once we stop the attack. Therefore, when he automatically connects, the handshake will be sent in the air and we will be able to capture it. This way, we will not have to sit down and wait for someone to voluntarily connect to the network. So, we've seen how to do this before, and it's going to be exactly the same command as we did it before. We used areplay-ng, we did --d-auth, then we specified a really large number of packets to keep the client disconnected for a long period of time. This time I'm gonna set this to 4 to only send 4 deauthentication packets. This way, my client will be disconnected for a very short period of time. They won't even feel that they got disconnected, but this is enough for the handshake to be sent because they will be disconnected, they will automatically connect, and when they do that, we will capture the handshake. Now, the next argument we want to set is the MAC address of my target. So we're going to do -a followed by the MAC address of my target. Then we're going to do -c followed by the MAC address of the client that we want to disconnect. So it's this client right here. I'm going to copy, paste it here, and finally we're going to give it the name of my wireless adapter in monitor mode, which is Mon0. And we are done. Again, I've spent a full lecture on this command explaining what a deauthentication attack is, so if it's a bit confusing, please go back and revise that lecture. Basically, all we're doing is we're using areplay-ng to run a deauthentication attack to disconnect this device for a very short period of time. That's why I'm setting this to only number 4. Then I'm using -a to specify the MAC address of my target, -c to specify the MAC address of the client connected to this network, and then I'm giving it my wireless adapter in monitor mode. Now I'm gonna hit enter and keep an eye on this side right here. You'll see the handshake will be captured in here. So we're gonna hit enter, the authentication packets are being sent, and perfect. As you can see, once the client connected again, we received the handshake. So now we can quit aerodump-ng, so Control-C, because we have the handshake now. It is stored in the file that we set after the write option, which is called WPA handshake. And in the next lecture, I'll show you how this handshake can be used to get the key for the network. From the previous lectures, we learned that when it comes to WPA and WPA2, the only packets that contain some information that can help us with cracking the key are the handshake packets. And in the last lecture, we learned how to capture the handshake and store it in a file. Now, the handshake does not contain any information that can help us to recover or recalculate the WPA key. The information in it can only be used to check whether a password is valid or not. Therefore, what we're going to do is to create a word list, which is basically a big text file that contains a large number of passwords. Then go through this file, go through the passwords one by one, and use them with the handshake in order to check whether this password is valid or not. You can actually download ready word lists from the internet, but in this lecture, I want to teach you how to create your own word list, and in the next lecture, I'm going to explain to you how the word list and the handshake are used in order to recover the password, and we'll see how to do that in practice. So in this lecture, we're going to learn how you create your own word list using a tool called Crunch. This is a really handy skill to have under your belt if you want to be a penetration tester, because you're going to face a lot of scenarios where a word list attack can become very handy. So using the tool is very simple. All you have to do is just put the name of the tool, and then you specify the minimum number of characters for the passwords to be generated. Then we're going to specify the maximum number of characters for the password. Then you specify the characters that you want to generate passwords from. For example, you can put all lowercase characters, all uppercase, you can put numbers, digits, or you can just specify a smaller number to make the word list smaller. You can also use the option T, which is an optional, to give a pattern. So for example, let's say that you were looking at the person while they were typing their password, and you've seen that the password will start with an A. So you can tell Crunch that the password will start with an A, and then give me all possible combination of passwords that start with an A. And after that, we use the -O option to specify the file name where the passwords are going to be stored. So we have a small little example here that will generate a list of passwords that start from 6 characters to 8 characters and contain these characters right here. So it's going to create combinations of 1, 2, 3, ABC, and the $sign. And it's going to store it in a file called word list. And these passwords are going to start with an A and end with a B. And it will generate passwords based on all possible combinations between the A and the B. So all of the generated passwords will always start with A and end with B. So let's have an example of the tool. Now the tool actually have a lot of options other than what we've seen so far. So if you just type in man crunch, you'll see all the options that you can set, and you'll see detailed description about all of these options. So it's actually really good. You can go ahead and spend some time to get familiar with the tool. Now I'm going to show you the example, and based on the example you'll be able to run all of these commands. But if you want to run or create some advanced word lists, then I highly recommend that you go over this. One of the really cool options that I want to highlight is the -P option. The -P option tells Crunch to generate passwords that don't have repeating characters. For example, when you specify all lowercase characters, you specify A, B, C, D, it will start by generating passwords made of A, and then A, B, B, and all of that. So when you do this, Crunch will actually ignore these type of passwords, and it will only create passwords that don't have any repeating characters. And that will reduce the size of the word list from the number of characters to the power of the length to the number of characters factorial. If you scroll down, you'll actually see more examples of commands and the type of word lists that will be created. So again, you can have a look on these and get yourself familiar with. Once you're done looking at the man, you can just press Q and you'll be out of it. And we're going to run our command here. So we're going to use crunch. And again, I want to generate passwords of minimum of 6 characters and maximum of 8 characters. And I want them to contain combinations of A, B, C. And let's say the digits 1, 2. Now in here you can actually keep listing things. You can list characters, you can list uppercase characters, or even symbols if you wanted to. Once you're done with listing the characters, we're going to specify the file to save it to, and we're going to save it in a file called test.txt. So the command is very simple. It's crunch, minimum length of the password, the maximum length of the password, followed by the characters that we want to use to generate passwords from, and then O to the file that the passwords are going to be stored in. I'm going to hit enter. And as you can see now, it's telling us that it generated 448,000 passwords approximately, and they're all stored in a file called test.txt. Now, the size of the file is 4 megabytes. And now I can open this file by doing cat test.txt, and as you can see now, we can see all the passwords that have been generated. I'm going to Control-C out of it because it's a huge file, and as you can see, it actually contains all possible combinations of ABC 1, 2. I also want to show you an example of using the -T option. So I'm going to set this to only 6 to 6, so it's only 6 characters, and we're going to use the -T option, which is the pattern option. And I'm going to tell it that I want the password to always start with an A. And then I want you to fill all possible combinations of characters between the A and the B. So I want passwords that start with an A and end with a B. And in the middle, at the @ you can fill all possible combinations of ABC 1, 2. Gonna hit enter. As you can see now, the number of passwords is much less. It's only 625 passwords because I've narrowed down the possibilities of passwords. Again, if I do cat test.txt, you'll see that I have all the passwords right here. So this is it. Tool is really useful, can be used in many scenarios. I highly recommend that you spend some time with it and also have a look on some of the existing word lists out there on the internet. Now, from the previous lectures, we learned in order to crack WPA or WPA2, we need to first capture the handshake and second have a word list which contains a number of passwords that we're going to try, and hopefully one of them will be the password for the target network. So right now I have both of these components and we are ready to go and crack the password. To do this, aircrack-ng is going to unpack the handshake and extract the useful information. The MIC right here, or the message integrity code, is what's used by the access point to verify whether a password is correct or not. So it's going to separate this and put it to the side, and then it's going to use all of the other information right here combined with the first password from the word list to generate an MIC, another message integrity code. And then it's going to compare this MIC to the one that's already in the handshake. If the MIC generated using this information plus the first password is the same, then the password used to generate this MIC is the password for the network. Otherwise, this password is wrong and it'll move to the next password. Again, it'll do the same. It'll use all of this information combined with this password, generate a new MIC, compare this new MIC to the one that's already in the handshake. If it's correct, then this is the password. If it's not, then it's going to move on to the next password. And it'll keep doing this through all of the passwords in my word list. If any of them generates the right MIC, then this is the password for the network. Otherwise, we won't be able to get the password. That's why the success of this attack really depends on your word list. So, let's see how to do this in practice. Right now, I have my word list right here. It's called test.txt. And I've actually manually added my password to the end of the list right here, just so that when I run the word list against the handshake, I will actually find the password, because the word list did not contain my password by default. I also have the handshake file right here, as you can see, and all of this is in my home directory, which is my root directory. So if I do ls in here, you'll see I have the word list and the handshake file. So we're ready to run aircrack-ng. So we're going to type the name of the program as usual, followed by the name of my capture file, which is WPA handshake01.cap. So far it's identical to the way that we used to use it with WEP. The only difference right now, because this is a WPA2 network, we have to specify a word list with the -w option. And the name of my word list is test.txt. So very simple. Aircrack is the name of my program. WPA handshake01.cap is the name of the file that contained my handshake. And I'm using -w to specify my word list file. I'm gonna hit enter. And as you can see now, aircrack-ng is running through the word list, testing each word in the word list one by one, as shown in this diagram, calculating an MIC based on this information and the word list, and then if the MIC is correct, it's going to tell me that this is the password. Now, the speed of this depends on your processor and the size of your word list file. So if you have a huge file, obviously it will take you longer time. There are also online services that you can try where you upload the Handshake, and they have huge word lists and they have supercomputers to run through these word lists and try to give you the password. Unfortunately, I can't share their links with you, but you can easily find them on Google if you search for them. And perfect, as you can see, we managed to find the key. It's telling us the key is found, and this is the key to the network. And this is the correct key because, as you know, this is the same key that we got when we exploited the WPS feature. So now we can go ahead and connect to the network, and we'll be able to run all of the cool stuff that I'm going to teach you in the post-connection attack section. Now, this is the only practical way known so far to crack WPA and WPA2 keys. There are methods to speed up this process, so you can use the GPU for cracking because it's much faster than the CPU. That's if you have a GPU. You can also use rainbow tables. You can also pipe the word list as it's being created in Crunch to aircrack-ng. This way you can create bigger word lists without using any storage on your computer. There are also methods so that you can pause your cracking process and then come back after a while without losing your progress. But the main idea is the same. The only way right now to crack WPA and WPA2 is through a word list attack. You can use social engineering, however, to get the password using an evil twin attack where you trick one of the users to give you the password. This is actually all covered in my advanced network hacking course. The cracking using the GPU, piping Crunch to aircrack-ng, getting the password using an evil twin attack, and much more advanced network hacking techniques. If you're interested in that, then I highly recommend you have a look on my advanced network hacking course. Check out the bonus lecture of this course, the last lecture of this course. It contains links to all of my other courses and the comparison between them. Okay, so through all the previous lectures, we've seen all the weaknesses that can be used by hackers in order to compromise WIP, WPA, and WPA2 encrypted networks. We've seen how they can use these weaknesses to crack the password and get the actual key to the network. We also seen that attackers are able to deauthenticate or disconnect any device from any network without the need to know the key to that network. And in the previous lecture, we've seen how we can modify the settings of our routers so that we can increase the encryption of our network, increase the security of our networks so that hackers can't use the attacks and get the password. Now, in order to apply the settings that we talked about in the previous lecture, you need to be able to access the settings page for your router. Now, each router has a web page where you can modify the settings for the router, and it's usually at the IP of that router. So first of all, I'm gonna check and get the IP of my computer or of my device, and I'm just gonna do ifconfig lan 0. And as you can see, this is the IP of my computer. So I'm gonna open my browser, and I'm gonna navigate to 192.168.0, and the IP of my computer was 25. Usually the IP of the router is the first IP in the subnet, so this is the subnet. At the moment it's 192.168.0, and I'm just going to add number 1 because that's the first IP in the subnet, and that will take me to the router settings page. And as you can see, it's asking me to enter a username and a password. Now, routers come in with a pre-specified username and password. You can check what's the default username and password, and then I highly recommend you change them after that. So usually it's written in the manual. So check the manual, see what's the default username and password, and then you can log in. Now, in some cases, the attacker might be doing a deauthentication attack against you, so he might be preventing you from connecting to your network wirelessly. So what you can do is you can connect to your router using a cable, using an Ethernet cable, and when you do that, then the attacker cannot use a deauthentication attack to deauthenticate you or disconnect you. So you'll be able to access your router settings using the wire, and then you can modify your security settings and change the encryption, change the password, do all the things that I recommended in the previous lecture in order to increase the security so that the attacker will not be able to attack your network and get the key. Now, the settings of each router are different. They depend on the manufacturer and even the model of the router. But usually the settings, the way that you change the settings is the same. And like 90% of the cases, the router is always at the first IP of the subnet. So all you have to do is you get your IP using fconfig command like we did here when we got it, and it was 192.168.0.25. That's the IP of my device. And then I changed the last 25 to number 1 to the first IP, and that is the IP of my router. Now, I'm going to navigate to the wireless settings. Now, as you can see, there's a lot of settings that you can change for your network, and we're concerned with the wireless settings at the moment. So, as you can see, my wireless is enabled. You can change the name of the network, you can change the channel, and the bandwidth and all that. So I'm going to go to the security, and as you can see now, I'm using WPA encryption with WPA or WPA2 authentication, and the encryption using AES and TKIP. And if I go on WPS, you can see that the WPS is disabled, as we said now. So basically, I'm not using web, so they cannot use any of the attacks that we spoke about that allow you to crack WEP encryption. I'm using WPA, which is much more secure, and I disabled WPS, so they cannot use Reaver to determine my WPS pin and then reverse engineer my password. The only way that the hacker can access or get my password is by obtaining the handshake first and then use a word list to find my password. Now, my password is very random, even though it actually doesn't use numbers or digits, just letters, but it's very random, so there is a really small chance of someone being able to guess that password. Now, there is another thing that I'd like to show you here is the access control, and using this you can add policies. So you can add an allow policy or a deny policy, and using that is based on the MAC address. You can specify MAC addresses that you want to allow to connect to your network. You can also specify MAC addresses that you can deny from your network. So for example, you can just, if you don't have many visitors coming to the house, or if you're in a company with a specified number of computers and you want to allow a number of computers to connect to that network, then you can just ask the people, get their MAC addresses, the people that you want to allow, and add them in an allow list. Now, even if someone has the actual key, the right key for your network, and they don't exist in the whitelist or in the allow list, they will not be able to access the network. You can also add a deny list, which is if you want to deny a certain computer or a certain person that you think are suspicious, you can just add their MAC address in the deny list, and they will not be able to connect to your network. So this is about it. As I said, the settings page usually look different. The names might be called different names, as in the names for each of these tabs. But usually the main thing is you should be able to access the router settings using the subnet IP and add the number 1, which is the first IP at the end. And if you're being attacked, if you can't connect to your network at all, then just use a cable and modify the settings like we discussed in the previous lectures. In this section, we're going to talk about post-connection attacks, so attacks that you can do after connecting to your target network. Now, it doesn't matter whether the target network is a Wi-Fi network or a wired or an Ethernet network. It really doesn't matter. As long as you gained access to this network, as long as you're able to connect to it, you'll be able to do all of the attacks that I'm going to show you in this section. Now, you'll notice once connected, you can do so many cool things. So you'll be able to gather detailed information about all of the clients connected to the same network. You'll also be able to intercept data and see any usernames, passwords, or any information they use on the internet. You'll be able to modify data as it's being sent in the air. So you'll be able to inject evil code and do so many cool things on the network. Now, to do all of the attacks that I'm going to show you in here, you have two options. The first option is to run the attacks against the virtual NAT network against the Windows machine. You just need to make sure that the virtual Windows machine is connected to the same NAT network as the Kali machine. Or you can run the attacks against real computers connected to your real Wi-Fi network, and you need to make sure that you have a wireless interface connected to the Kali machine, and the Kali machine needs to be connected to your target Wi-Fi network. Now, throughout this section, I'm actually going to be using both options. So I'm going to be running some attacks against the Wi-Fi network, and I'll be running some against my virtual NAT network, just to make sure that you're comfortable with running all of these attacks in different environments and in different networks. Because like I said, it doesn't really matter how you gained your access to the network. The network type doesn't really matter either, as long as you are able to connect to the target network. Now, to practice some of the attacks that we're going to learn in the future lectures, you need to have a target machine or a victim machine. So this is a computer that you're going to target and try to hack and test the attacks that we're going to learn against. So you can do this against any machine, but I highly recommend installing target machines as virtual machines. This is great because it won't break a real computer for you if you actually break something. It's also very easy to fix. Even if you have a computer that you don't care about, it's very easy to fix virtual machines. You can just remove it and reinstall it, or store a snapshot and go back to it. Now, as we all know, Windows is a very common operating system. It's used by a lot of people. So in this lecture, I'm going to show you how to install Windows 10 as a virtual machine so that we can test some of the attacks that we're going to learn in the future against it. So we'll use this machine with scenarios that mimic a normal user that is just using their Windows to browse the internet or do whatever normal people do with their machines. So Microsoft has actually released a free versions or free virtual machines of Windows that you can download and use. These are free and you're allowed to download them, and we're downloading them from Microsoft's website. So you need to go into this link to download it. As you can see here, this is the same link. So make sure you select what host operating system you have. So if you have Windows, you click on the Windows tab. If you have Mac, on the Mac, and if you have Linux, on the Linux. I have a Mac, so I clicked on the Mac tab. And from here, make sure you select Windows 10 Stable. And make sure you select the VirtualBox image. So these are all applications that allow you to install virtual machines. At the moment, we're using VirtualBox for everything. So just make sure you use the VirtualBox image. Once you do that, you will have a zip file like this one. Uncompress it, and you will get this file right here. Now, this is a virtual machine, a VirtualBox virtual machine file. So I'm going to double click it. And as you can see now, VirtualBox is asking me to import this machine, and it's already set up the settings for it right here. Now we can import it the way it is and then modify the settings. Now, as you can see here, I have my Windows installed right here, and I'm just going to boot into it by, actually, I'm going to modify the settings first, because I remember I think it gave it 4 gigs of RAM, and I think that's too much. So I'm going to go in to here, and I'll set this to 2 gigs. And yeah, I'm set that, okay. And I'll start it. And as you can see, Windows starting straight away, no need to install it. It's already installed and ready and given to us by Microsoft. Now, if you get asked for a password, then the password is literally password with a capital P and a 0 instead of the O, followed by an exclamation mark. Now, as you can see, we have a fully working Windows machine right here, Windows 10. So it's our second victim or target machine. Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network and one of the devices connected to this network is your target. Now, for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now, there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now, I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network, and as you can see in here, it's telling me that wired connected. Now, I have my virtual Windows machine right here. It is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now, the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now, or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -R to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16, and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1, and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24, and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network. And note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now, if I press Q, this will quit the program. And right now we have a list of all the connected clients to the same network. Now, like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is, right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer and a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now. And if I do ifconfig, it's still not showing up. So I'm going to connect it from my devices, USB, and click on the adapter name. And let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0. And what I'm going to do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm going to go to my network manager. I'm going to click in here, and you want to click on select network. And as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP. And as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now this did not work, and I know why. In order for this to work, you actually have to disable the NAT network. So to disable the NAT network, we're going to go on devices, we're going to go on network, and we're going to uncheck the connect network adapter. So now once done with this, if we just run the exact same command again, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer. And you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines. And as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now in the previous lecture we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using Zenmap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type Zenmap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the nmap command that will be executed when I hit the scan button. So like I said, ZenMap, what we're using right now, is just a graphical interface that will run this nmap command in the background and show me the results. So if you know a custom nmap command, you can put it here, or if you just want to see nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here. And in here, we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router, and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.1.10 is a HTC device, and again, this is a HTC phone. This is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.1.12 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the ping scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we've seen before with the ping scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open. So this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is, because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on ZenMap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone. It's running iOS. So this is really, really good. Now if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running, so we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service, and the server is Mediatomb UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions, and if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now, obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now, by default, iOS devices do not have an SSH server. Usually, when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with Open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try if you discover a phone like this in the same network. It's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now this is a little bit ahead of time. We are still in the network hacking section, so don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here. And like I said, once done with the course, I think the Nmap book would be a really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course. Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So, a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets, so instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They're all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is gonna say, I have 10026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses, and the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARP-A, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARP-A, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10021. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams, and right here we have a diagram of a typical network, and you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim, so the access point will update its ARP table and it will associate the IP of the target with my MAC address. we'll do the same with the victim. So we'll send it an ARP response. We're gonna tell it that I am at 10.0.2.1. So it's going to update its ARP table and associate the IP of 10.0.2.1 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection, and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now, the main reason why we can do all of this is because ARP is not secure. Because first of all, clients can accept responses even if they did not send a request. So, as I said before, we're going to send a response to the access point and a response to the victim, telling them that I am at a specific IP. Without them asking who am I, or without them asking for this IP, I'm just going to send a response, and they're going to accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this, and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm going to tell it that I am at 10.0.2.1. It's going to trust and believe this, even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now, there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I covered this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP Spoof. Then, in the next lectures, we'll use a tool called BetterCap because it has more features. Basically, the main reason why I want to cover ARP Spoof in this lecture because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So, you can only use this tool to redirect the flow of data and make it flow through your computer, and then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now, using ARP Spoof is very simple. First, we're going to have to type its name, so it's ARP Spoof. Then, we're going to do -I to specify the interface that is connected to the target network, and in my case it's ETH0 because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm gonna be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're going to do -t to specify the target. And my target is at 10.0.2.7. As you can see in here, that's the IP of my target. And I'm going to have to give it the IP of the gateway, which is at 10.0.2.1, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm going to clear the screen. And again, I'm going to do ARP spoof IETH0. And the target this time is going to be 10.0.2.1 and 10.0.2.7. So right now we're going to be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks. All you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm going to hit enter here, and I'm going to hit enter here. And now if we go to the target machine and run the same command, ARPA, you're going to see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sysnet IP version 4 IP forward. And as you can see, this command gets executed with no issues. And right now, this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram. And then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So, as you can see, a very simple tool. It allows us to redirect the flow of data so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. Previously, we learned what ARP spoofing is and how to use it to intercept connections in our network using a tool called ARP Spoof. I covered this tool because it is simple, reliable, and available for a number of operating systems. Therefore, learning how to use this tool can be useful in so many scenarios. However, in this lecture and in the next lectures, we're going to be using a tool called BetterCap. BetterCap can be used to do exactly what we did with ARP Spoof. So we can use it to run an ARP spoofing attack to intercept connections. And it can be used to do so much more. So we can use it to capture data and analyze it and see usernames and passwords. We can use it to bypass HTTPS and potentially bypass HSTS. We can use it to do DNS spoofing, inject code in the loaded pages, and so much more. For now though, I'm going to show you how to install the tool and give you a quick overview on how to use it, and we'll go over all of that in the next lectures. So I'm going to go to my Kali machine here, and as usual, when we want to install something, first we need to make sure that our sources are up to date. So we're going to do apt-get update. This ran with no errors, perfect. The next thing that we need to do is install BetterCap. So we're going to do apt-get install a package called BetterCap. So we've used this command before. apt-get is the package manager that we use to download and install packages. We're saying we want to install a package called BetterCap. So I'm going to hit enter. This will ask you if you want to download it, and you will have to press Y from your keyboard. For me, I've already installed it, so that's why it didn't ask me. And as you can see, now it is downloaded and installed. So I'm going to clear my screen. And to run BetterCap, all I have to do now is just type its name, BetterCap. Now, as usual, if you want to get more information on this command and how to use it, you can do --help. And this will give you a complete help menu. But you don't really need to worry about this now, because we will be using the tool a lot throughout the course, and you will learn a lot as you use it. So I'm going to clear the screen again. And to run the tool now, I'm going to type BetterCap, the name of the tool, followed by -iface to specify the interface that is connected to the network that I want to run the attacks against. And as you know, to get my interface, we can just do ifconfig. And I'm going to be running this against my NAT network, which is ETH0 is connected to. So I'm going to set my interface to ETH0. I'm going to close this. And I'm going to hit enter to run the tool. And as you can see now, we're inside the tool. We have a different prompt now in which we can use the commands of BetterCap. Now, as you can see here, it's telling us that we can type help to get a list of all of the commands that we can use with BetterCap. And since we don't know how to use it, I'm actually going to type help. And perfect. As you can see, we get a full list of all of the commands that we can use. Again, I'm going to use it with you now as we go through the course, so you can have a quick look on them, but don't worry too much about them. What's really important and you need to pay attention to right now is the modules. So these are all of the modules that we can use, or all of the things that we can get BetterCap to do. And as you can see right now, none of them is working except for the event stream, which is basically the module that runs in the background to handle all the events. Now, you can type help followed by the name of any module you want. And this will show you a help menu that shows you how to use this specific module. For example, I want to show you in this lecture the net.probe and the net.recon modules. So, since I don't know how to use them, I've typed help, and I'm going to follow it by the name of the module, which is net.probe. I'm going to hit enter, and as you can see, you'll get a description of what this module does. So basically, it keeps sending UDP packets to discover devices on the same network, and we can do net.probe on to turn on the module, and net.probe off to turn it off. You can also see all the options that you can modify for this module, and I'm going to talk about options and how to modify them in the next lecture. So for now, I'm going to keep all these to the default option, and I'm just going to do net.probe on to turn it on. And as you can see, this will automatically start discovering clients connected to the same network. So the 10027 right here is actually my Windows target machine. So if I go to the target Windows machine right here and do ipconfig, you'll see its IP address is 10027. So this is just another way of discovering connected clients quickly using BetterCap. And what you didn't notice right now is when we started the net.probe, it automatically started the net.recon. To confirm this, so if we go up right here, you can see the only module that was running is the events.stream. And now, if I do help, you'll see I actually have two modules running, the net.probe, which we just saw and we turned on manually, and the net.recon, which got turned on automatically by BetterCap. The reason for this is because the net.probe sends probe requests to all possible IPs, and then if we get a response, the net.recon will be the one detecting this response by monitoring my ARP cache and then adding all of these IPs in a nice list so we can target them. So now, because the net.recon is actually running, we can do net.show to see all of the connected clients. And as you can see, we get a nice list of all of the connected clients. We can see their IPs. We can see the corresponding MAC addresses for these clients. And it can also show you information right here about each one of these IPs. For example, it's telling us that this IP right here is the IP for ETH0. So this is the IP of this computer. It's also telling us that this IP right here is the gateway. This is the IP of the router. And you can also see at the vendor in here, it's attempting to discover the manufacturer of the hardware used in each of these clients. So as you can see for the gateway, it thinks that it uses a Realtek chipset. Now you can also see here the 10.0.2.7 device. Like I said, this is my target Windows device right here. So that's it for this lecture. I just wanted to give you a quick overview on how to get help about a specific module, how to run a specific module, and analyze the results that it returns. And in the next lecture, I'm going to show you how we can run an ARP spoofing attack using BetterCap to intercept the data and read usernames and passwords that flow through the network once we become the man in the middle, once we intercept the connection.